Hello, in this session we are going to talk about how to prepare your project for KMM. Obviously, the first question we should ask ourselves is what do we need to do it? As you can see nowadays, there is a lot of cross-platform solutions to make mobile app, but it is still difficult to choose the best technology that fits our needs. In this talk, we suppose that KMM is the chosen one for our app, and we will see together some thoughts that can we tackle to implement it. Before we begin, I'm Oussama Ben, Senior Android Developer at Sphere based in Paris. I have been developing Android app for more than 8 years, and you can find me on Twitter for any question. And I am so excited to share with you this talk, and great thank for the organizer of DroidKaigi for giving me this wonderful opportunity. So let's get started. At the beginning, I just want to share two clauses as a disclaimer. The first one is Kotlin Multiplatform is continuing to move along the road to beta state 2. It is postponed until the new memory model becomes the default, which is expected to be the case no later than autumn 2022. That means you expect migration issues. Language features and tooling may change in future Kotlin versions. The second one is architecture still a subjective topic, and we have not one single way to make an architecture that fits our project. So what to expect in this presentation? We will see an overview about KMM, what is and how to implement it from scratch or an existing project depending on its architecture, and what is the normal libraries that comes resolving some issues. In the first part, we will see what is KMM, how to make it work, and why. So KMM, which is the Kotlin Multiplatform Mobile, is an SDK designed to simplify the development of cross-platform mobile application. It gives the opportunity to have a shared module that contains common code between iOS and Android apps and write platform-specific code only where it is necessary. For UI, there is Compose Multiplatform that allows extensive UI code sharing between Android, desktop, and web. The basic idea of KMM is to create your own code-based modules and connect them to your native projects. Thanks to Kotlin, which offers specific version of Kotlin for each native platforms, JVM, JS, and native, each version includes special extension, tools, and libraries specified for particular platform. As you can see, Kotlin code will be compiled into JVM bytecode for Android, but native Kotlin includes an LLVM-based backend for the Kotlin compiler and native implementation of the Kotlin standard library. Compile Kotlin code to native binaries, which can run without a virtual machine such as iOS. So if we can see, the common Kotlin code could be shared easily, independently, but the problem comes when we need to write platform-specific code. For that, there is two features provided, expect and actual, that are almost stable, but migration steps may be required in the future. The expected declaration must be done in the common package that act like an interface which define your needs, and platform source sets must provide the actual declaration corresponding to the expected declaration. As you can see, for Android, we use the android.os.build.version, and for iOS, we can use UI device.current device. For now, let's get deep and see how KMM looks into the project. We will see how to implement KMM from scratch, then what we can share in monolithic app, modular app, by layer and by feature. The first example is how to start a KMM project from scratch. What you can do is to create a new KMM project in Android Studio, and it will look like this. At the top, we have our Android app as usual. Below, we can find the complete iOS app with its pods files, and the bottom, we find the new shared module where we can put our shared code. After collaboration between Android and iOS team, you can share the most layers and just write it once, such as the API services, database, repository, and use cases. All these modules could be written in Kotlin just once and shared between iOS and Android. In that case, the platform code can be just Jetpack Compose for Android and SwiftUI for iOS, with their view models and event models and state models. The next example is a monolithic app, where the dependency graph is just our app with a lot of external libraries. In my opinion, trying to do KMM in that case seems to be complex, but it can be possible after moving some stuff to microservices and then think about mutualization. But it is still possible for a new feature to make it independent and shared via KMM. Now we can find a basic modular app that the graph looks like this, where the app depends on three modules with the principal layers UI, domain, and data. In this case, UI is now recommended to be shared as usual. The domain layer can have a lot of use cases that can be shared easily, so we can split the domain layer or extract the shared content. For the data module, we can find a lot of dependencies that make exploring new technologies more complex. So the first step is to split and modularize the dependencies in different modules. After that, we can find clearly what to share. Then, the core module, which often looks the more complex module, also should be modularized before going shared, such as core data, core test, core design. At last but not least, modular architecture by feature, when we can find a separate module for each feature, which include UI module, domain module, and data modules. For this example, we can extract the UI module and combine the domain and data module into shared module. And for the lower layers, you can easily migrate to KMM if you have separation. As you can see, if you have a separate module just for networking, it will be easy to migrate to multi-platform library without impacting the rest of the app. We will see this in details in the next slide. In fact, if we take this example of layering, we can see that Android use Jetpack Compose and iOS use SwiftUI. Then we have the view model with potentially event and state models. The view model inject use case. The use case inject repository that use remote data sources with API services and local data sources with database. And in the lower layer, Android can use retrofit for networking, but iOS use allow modifier, for example. In addition, for the database, Android can use Room and iOS use Realm, for example. In that point, you can recognize easily that use cases, repository, API services, and database can be shared between the two platforms, but the difficulties comes in the last layer where we need to have a multi-platform Kotlin library that works for the two platforms. That's why we have KTOR library comes to the rescue for networking, and SQLite for database. Now, thanks to these two Kotlin libraries, you can write code once and it works for Android and iOS. On the other hand, using the dependency inversion, we can still use our native library and just share the interface, but it is still not a big deal compared to shared library. As you can see in this example, you can still use retrofit for Android and do Alamofire for iOS and share only the interface. Next, we can modularize our data modules and just have one single responsibility for each module data. As you can see, you can have a module for networking, module for data store, for data test, and for database. And for the external libraries that could be used in UI and domain layer, it will be useful to extract it into a library module and expose an interface inside domain layer where use cases can consume it. And the other benefit is that the UI layer does not need to know about the library. Now let's see what is the modularization benefits and the impact on KMM. The very first reason is to speed up builds. Basically, the Gradle works great with small parts thanks to parallelization. In a single module, all the tasks run sequentially, resulting in a very long compile time. But if we take several modules, we increase the number of tasks, but they are executed in parallel, which results in a very fast compilation time. If we change some code also, only the specific module will be recompiled instead of recompiling the whole project. The second reason is good for business. With a faster time to market, with just one module we can go live faster and we can afford a KMM module for the two platforms at once. The third benefit is scalability. So with a modular architecture, every feature can be achieved with an independent team without the need to understand all application specification. If another developer comes to maintain only one module, it takes a fewer time to understand the feature and fix the bug. Each team will also be responsible for the maintenance of their modules. That gives us the possibility to create a KMM team to develop a multi-platform module independently. Then the most important benefit is the ability to discover and explore new technology. So in a separate module you can try different language and new technology without breaking the app and making a huge change. And of course, in this case, discovering KMM. And last, as we showed earlier, we have small parts that can be easily maintained and easily tested. So we don't need to go through multiple modules to find a specific view to test. Each module can test its own code quickly with a reliable test. Now let's dive deep into the implementation of KMM. And let's start with the simple module to handle a part is the UI module, because it is recommended to not share the UI module. The best solution is to make it in a separate module. Like in this example, we have the home feature module, and we can create a single module that is our responsibility to display data and handle user interaction. With that isolation of UI, we can migrate to another UI technology without the need to impact the whole project. Today, it can be with XML or Jetpack Compose or maybe Flutter or any other technology that fits our needs. Next, we can make the focus on the core module and retrieve the most valuable classes that seems to be shared at once and doesn't need recurrent updates. In this example, we can share data models, or maybe you can share state or event models or utility classes that works on Android and iOS. After that, despite we can still working with native network libraries, but still useful to have shared library that handles the two platforms. So in the shared data network module, we can find 3 blocks exactly like any other shared module, and we should define the code-specific platforms as well. At first, we can start with the common main, where we declare the expected class that each platform should return its specific implementation. Then we can go to Android main package and specify the actual behavior that implement Android HTTP client. And finally, in the iOS main, where we define the iOS HTTP client provided by Darwin that will manage our networking in the iOS platform. For the shared module, which is the umbrella for all shared submodules, we can make our domain and data classes and potentially a view model helpers. Maybe defining platform-specific code into shared module will lead to monolithic module. For that, I think it's good practice to share submodules and declare the specific implementation and make it as a dependency for the shared module. And with that, we can find our shared module dependencies like that. We can set our shared code as API dependency that makes all its public API accessible, and set our data network shared module as implementation. After settings all that, our Android app will depend on our UI module and the shared module, potentially the other shared module if we need to define the dependency injection module in our app module with Dagger or Elt. And for the iOS app, which will be provided with shared umbrella module that includes shared core and data network, and the only things that is missing in the UI is the UI module to make the the iOS app working. We will see next some other example of Kotlin multiplatform libraries that comes to resolve some issues of sharing. Because with KMM, we will have Kotlin code in iOS project That's why it is more important to have an Xcode plugin. So it's a plugin in Xcode IDE for Kotlin debugging and source formatting. Then, as we mentioned before, Ktor library, specifically Ktor HTTP client, that facilitates networking in Kotlin Multiplatform Mobile project for Android and iOS. The goal of Ktor is to provide an end-to-end multi-platform framework for connected application. The Kotlin X, coroutines and serialization, two library for which come with a multi-platform support. Next, the SQLite library that generate type-safe Kotlin APIs from your SQL statement, and it verifies schema and statement and migration at compile time. And also it provides IDE feature like autocomplete and refactoring, which make writing and maintaining SQL simple. Then with KMM we could not use yield because yield still specific to Android. So one of the options that was ready for KMM is coin. Maybe it will be a complex task to migrate the whole app from yield to coin, but it is still possible to make coin for the shared module and yield for the Android app. Then one of the needs that comes with KMM is sharing API keys. This Kotlin build config comes to enable us passing securely our API key for Android and iOS. Another common challenge is to share resources across platforms. Mock resource is a library that enables us sharing strings and images from shared module. If you think to share state and event models, maybe you will encounter some complexity for sharing sealed class. Here it comes Mokuka Swift that generates Swift-friendly API for Kotlin native framework. At the end, you may need a multi-platform library for logging, and here comes Kermit from TouchLab. In conclusion, KMM is promising technology that many companies start adopting it despite it's still in alpha. That's why I tried in this session to adopt the KMM approach in our daily coding routines to make our project more maintainable and open for new technology exploration. So if we find that our project is ready, we can start small by a simple library or integrating Ktor or SQLite. Secondly, maybe it's time for keeping an eye on iOS team, learning and exchanging ideas and architectures. Third, make your project as modular as possible and open for integrating any new module independently. Finally, do not forget to join KMM community where we can find help and learn. And finally, thank you so much for listening.